Hello, Legacy students. Marsh here. So today we're going to be solving log equations with log properties. You want to have that foldable on you. That is, it's just a small sheet of paper with information on it. So types of log equations that we have solved and one that we're working on today. So we have solved with a log on both sides. We have solved with logs on one side, and what we are looking at today is how do I take care of these logs when they're on two of them on the same side? So first of all, let's do a little bit of review. How did I solve logs when we had a logarithm on both sides? Well, in our case, we're just going to think about things making property of equality, just stuff that are equal, correct? We're just going to make things equal. Well, if I have log of 5 on both sides, we just get to say, well, let's just set the insides equal to one another, right? And then we would solve, so it's subtract x, add 7, and I would get 3x equals 12, so x equals 4. Now, if you remember when we solved log equations, we always had to check if I substitute inside of a log, is it negative or 0? Because if it's either of the two, we cannot continue, right? So we always plugged it in. We went, oh, that's 9 and that's 9. So 4 definitely does, in fact, work in our problem. Now that's if I had logs on both sides. What if I had log on one side? Well, we got the logarithm alone. So we didn't have like a number in front of the log or a number outside here. And then we just converted to exponential. So we said, well, 2 to the 5th is x minus 6, which would be 32 is x minus 6, right? So x is 38 for our answer. Plugged it back into the log. We made sure that it in fact does in fact work. No negatives, no 0, and we are all good there. Now, what about multiple logs on the same side? In this case, what we need to do is we need to condense down to a single log. We're going to convert it then to exponential. And just a reminder, we do need to make sure our logarithm is not negative, nor is it 0, so that we check our logs. So let's first condense this log into multiple pieces. So first thing, I notice that there is a subtraction on this log. And something to also keep in mind, back up a little bit, I can't move it over here because that would be 3 plus. That's why I can't like just say, oh, just drop the logs, Marsh. Can't do that because this log would have a 3 with it. So I'm going to condense it. Subtraction, we know, does change into division when we are condensing. So I'm going to show my condense here. Log base 2 of, and it's numerator, 5 plus 2x divided by 4 minus x. That's equal to 3. The log is alone now, and it's a single one. So now let's convert. So I'm going to go 2 to the third is equal to 5 plus 2x over 4 minus x. I know 2 to the third is 8. I have to move over here. I'm going to run out of room. 2x over 4 minus x. You know what? I'm going to put this over 1, and I'm going to cross multiply since it's a fraction equal to a fraction. And I'm going to get 5 plus 2x equals, and then multiply the 8 by both of those. I will get 32 minus 8x. Let's add the 8x to both sides. I'll get 10x equals 32 minus 5. I believe I will get 27. And then dividing by 10, we will get x equals just 27 tenths or 2.7 if you want to give that an answer as well. Now, double checking. Got to check our solutions. Okay, there's only a solution, but check it. If I plug in 27 tenths in for this x, I'm not going to get a negative nor a 0, so we're good there. And 27 tenths is the same as 2 and 7 tenths. So if I subtract 4 minus that, I'm definitely not going to get a problem. So that one does in fact work. Let's try another one. Now notice I have to condense over on the left here. There's a plus. We know plus turns into multiplication. So that means my two values inside of those logs are going to be multiplied by each other. So it's going to be log base 4 of 8x squared, right? Because 2 times 4 is 8. Now let's convert. 4 cubed is equal to 8x squared. 4 cubed is the same as 64. So I'm divide both sides by 8. I'm going to get 8 equals x squared. Solving, square root both sides. X equals, well, the square root of 8. I'm going to simplify it. It'd be 2 square root of 2. And because I solved using a square root, I do have a plus or a minus. Now, let's make sure. Nothing's going to happen here because there's no x. But if I plug in a positive 2 square roots of 2, it'll turn bigger, right? Not negative nor 0. If I plug in a negative, we are also going to square that, and it's going to become positive. So both of these answers are, in fact, correct. And that is the end of this video, Sabers. So as long as you got those log properties, I know that this is not a terrible lesson. Just make sure you got those properties locked down, and then you will be able to accomplish it. Until later, see you later, Sabers.